Hello everyone. So welcome to a new playlist on some of the example problems on KVL. So this is going to be a dedicated playlist where I will be solving a few problems on KVL. What is KVL? Kirchhoff's voltage law, that is used in electrical circuits. Now KVL can be applied for both AC circuits and DC circuits, and since it is easier, first I will start with DC circuits. Some of the problems. So the question what you are seeing on the screen, find the value of V in the following circuit using KVL. So here the voltage source V, how much is it? That is the question. And the information that is given is the circuit diagram with some resistors and all, and then here the current is 1 ampere flowing in this branch. So this is an application of KVL. So how you can apply KVL to find the what is the value. Okay, so now how to solve this kind of problems. Okay, so how to solve this kind of problems, in fact you can just do it by observation, but then since I am making the first video, I am just explaining this. See, before that let me make a small circuit and then explain. See, let's say this is some element, this is some element, and another circuit element. So like this I can have a circuit like this. Now if I mark this point, let's say A, B, C, D, E, and these 2 points are same potential because there is no element here, it's a short circuit. So this point, everything can be considered as E. Now for for our consideration, let us consider this as the ground potential. That means 0 volts. So therefore voltage of E is nothing but ground potential, it will be 0 volts. This is my assumption, or it's like a given data. Sometimes point C can be considered as grounding, point D can be considered as grounded, whatever. So in this example I have given E. Now I can determine the other voltages or the relations like this. See, let's say what is the voltage at this point? At this point the voltage is VA. So usually we use the capital V and then the subscript to denote the voltage at that point. And here it is VB, and here it is VC, VD, and VE, anyway I said it is 0 volts. And so if I start from a point, if I go to different values, see, from here to here my voltage will increase to VA. So now from here to here again VB, it will increase, again VB to VC, again the voltage will increase. So like this we have a series of voltages like that. Now it also depends on what it is here. So for example here, let's say there is a battery here. Okay, so instead of this element there is a battery. So and the battery is something like this, 50 volts. So the positive is down and the negative is up. So now when I go from VA to VB, I am going from positive side to negative side. That means VA is at higher potential compared to VB. So in that case, VA to VB, when I go, the voltage will reduce. And if the battery was the other way, it voltage will increase. Now same way in the case of resistance. Let's say the resistance is like this. Now if the current arrow, let's say like this it is. So current is flowing from in this branch, the current is flowing in this direction, VC to VB. So in that case what happens, the potential of C will be higher than the potential of B. So therefore we can write VC will be greater than VB in this case. So like this we need to see for if there is a voltage source, we have to see, look at the positive negative terminal of the voltage, and if there is a resistance we have to see the current direction. So now comes to Kirchhoff's voltage law. So what Kirchhoff's voltage law it says is that if you take any loop, okay, so here this is the loop. So starting from here going A, B, C, and again coming to E. So this loop is one loop, and this is another loop. There is another loop also. There is an overall outside loop is also there. So in any loop, if you take the voltages, all of them, the algebraically, if you take their according to their sign, whether voltage is increasing or decreasing, etc. So by the time you come to the starting point, the voltage becomes 0. So that is the KCL. So we can say sum of the voltages in a loop is equal to 0. This is the Kirchhoff's voltage law, KVL. Now, in order to understand this, the best way is to do some example problem. So let's look at this problem. Now, 1 ampere is flowing from this point to the right. So 1 ampere into 5, according to Ohm's law, I into R, 5 volts is the voltage drop here. Now the same 1 ampere will flow, because this is the same branch, will flow in this also. 5 more volts will drop here. Okay. So now the question is, so if I say this is 5 volt, this is 5 volts. So the drop in this is 5 volt, the drop in this is 5 volt. Now compared to this point, what is the potential of this point? So compared to this point, the potential of this point will be 10 volts, because if there was 10 volts here, then it drops here by 5 volt, again it drops here by 5 volt, and by the time it comes here, it becomes 0 volt. But in this case, this is not 0 volt, this could be any other. So for example, here it is 7 volts, then here it will be 17 volts. Here if it is minus 3 volts, then here it will be 7 volts, because minus 3 to 7, the difference is 10. So it is all relative. Okay, let's make it A and B. So then I can say VAB is equal to 10V. That means voltage of A with respect to voltage of B, or taking B as reference, what is the voltage of A? It is plus 10 volts. Now if that is the case, what will be the current here? So the B point is same, so here it is 10 volts, so 10 by 2 will be 5. So voltage V by R is I. Okay, so 5 amperes is the current here. Now the current leaving from this point A is 5 amperes here and 1 ampere here. So the current here will be 6 amperes according to Kirchhoff's current law. In fact, we are using both KVL and KCL, Kirchhoff's current law. So here 5 ampere plus 1 ampere, 6 amperes current. Now if this 6 amperes current is going like this, 5 here and 1 comes back here, then again 6 amperes will go here. If 6 amperes are coming here like this, flowing through the resistance, then the voltage drop will be 6 into 3, 18. 6 these are 18 volts. So 18 volts will be the drop here. Now question is, which side is higher voltage? So obviously this side will be higher voltage and this side will be lower voltage. Okay. Why? Because the current direction is like this. So if I mark this point as C, then I will say voltage of C with respect to B is 18 volts. So therefore, now I want to know what is, let's call this point D. Okay, so what is the voltage of D with respect to voltage of C, I want to know. So I want to know VDC. I want to know voltage of D with respect to voltage of C, taking C as a reference. So now I can apply KVL. So for this, you apply KVL from C to D. So my starting point is C and my ending point is D. So what is the route? I have a shortcut directly, but I don't know the current in this. So I cannot take this route. Another route is like this, but I don't know the current in this. So let us take the other route where we know the current. Now from C to this point, I know that the current is 6 amperes and 3 ohms, so 18 volts. But here C is at a lower voltage and this point B, this is also point B, same. So B is at a higher voltage. So my voltage will increase. Okay, so I will say plus 18 volts. So I reached this point. Now from here I can go up or I can go this way. Both are possible. Let me take this shortcut. Okay, so because I know this current. Now you see 5 into 2 is 10 volts. Already VAB is 10 volts, we know. And A is at a higher voltage because from A the voltage is coming, current is coming to B. So therefore this is plus 10 volts again, because I am going from lower potential to higher potential, I use plus. So by the time now between A and D there is no resistance element. So voltage of A is exactly same as voltage of D. So therefore here I am getting 18 plus 10. So that is 28 volts. So therefore I can write here VDC is 28 volts. So now if VDC is 28 volts and 10 ohms is there, so then definitely here it will be 2.8 amperes. Because D is at higher voltage than C, the current will be like this, 28 divided by 10. Current is voltage by resistance. So 2.8. Now what is the current here? So it will be 6 plus 2.8. So it will be 8.8 amperes. So 8.8 amperes is the current. Therefore, what is the voltage drop here? 8.8 into 2. So that will be 17.6 mentally calculated. So here the voltage drop is 17.6 because 8 to the 16 and again 8 to the 16 and 17. Okay, so that will be 17.6. Now out of the 17.6, which side is higher potential? So left side will be higher potential because current is going like this. So you have to put plus minus. Sorry. We have to put plus and minus where the potential is higher. So here also for 18 I'll say plus minus, and here also plus minus plus minus. Just I'm giving the sign so that you can understand it. So now finally I want to calculate voltage of this point with respect to C. So I want to find out, let's say E here, VCE. I want to find out voltage of the battery is nothing but VCE. So I can take root from C to E. Okay, so apply KVL from C to E. So now C to E I can go via D because now I know this current. Okay, now C to D, what is it? 28, right? So VCE is nothing but plus 28 volts. Okay, because C to D I gain 28 volts. Again from D to E I gain 17.6 volts. So plus 17.6 volts. So this total will be 0.6, 45.6 volts VCE. So that is nothing but our V. That is the final answer, 45.6 volts. Okay. So this is how we use the KVL. Now you may get a doubt. What if I take another long route? Okay, so any route you take, it will be same. Okay, so for, just to prove it, let's say I want to calculate what is okay, I want to calculate this voltage, that is, let me just fold the paper like this so that I can write it here. I want to calculate VDE. Okay, so voltage of D with respect to E. Now I can apply two routes. So, okay, one route is directly E to D. Okay, so another route can be, I will start from E, then I go to C, then I go to B, then I go to A, then finally I go to D. Okay, so two routes are there, E to D. So both the routes will give me the same value. So let me demonstrate it to you. Now applying to find out VDE, applying Kirchhoff's voltage law from E to D directly. So E to D, you see 8.8 amperes into 2, 17.6 volts. E is at higher potential. I am going towards lower potential. So I am losing my potential. So therefore VDE is minus 17.6 volts. Okay, so this is the direct route. So now let's do the other longer route. Okay, first E to C. Now VDE is equal to, see, now I go from E to C, that means positive side to negative side, and this one is 45 point, we just calculated the value 45.6. So I'll get minus 45.6. Okay, so that is the first element. Now from C I'm going to B, and 18 volts already we calculated that, but from positive side I'm going towards negative side. I'm sorry, this side will be plus and this side will be minus, because this is a higher potential, the current is going like this. Okay, so from C to B I am gaining 18 volts. Okay, so because This is at lower potential, this is a higher potential. So plus 18. Then I'm at B. Now I have two routes. So let me take a longer route. Okay. So here I'm gaining 5 volts here. Again I'm gaining 5 volts here. So plus 5 and plus 5. So finally I'm reaching at A. A to D nothing is there. So this is my total value. So now let us see. See, minus 45.6. So what I can do, first I will add these positive terms. Okay, so this becomes 28. So minus 45.6 plus 28. Now if you do this minus 45.6 plus 28, you will get exactly minus 17.6 volts. So irrespective of the route you take, it will be same anyway. So this is how we calculate we use the KVL. Now KVL you can use any route. So from C to A you can go directly like this, or you can go left, go up and then go like this, or you can go like this, or you can go straight like this. So any direction you go from one point to another point, as long as you take the conventions correctly, you will get the same potential difference. Now if I start at a point again come back to the same point, obviously the net potential difference will be 0. Okay, so that is what is the Kirchhoff's voltage law. Summation of voltage in a loop is 0. Okay, so I think I have combined little bit theory and then I solved a problem. So that's why this video is little longer. But then we will solve 4 or 5 more problems on KVL just to improve your understanding. See you in the next video in this particular playlist. Thanks for watching.